G'day guys, I just wanted to give you a quick update on the panel meter situation. I made a video on one of the panel meters where we bodged in these resistors and then trimmed one of the resistors with some more resistors to get the accuracy right. And then I made another video where I modified one to get rid of the oscillation problem. Now, when I modified the one to get rid of the oscillation problem, I added two 10 microfarad caps here, X7Rs, where before there was like I think an X5R 10 microfarad, and I had also put a diode from here to here, from the output of the regulator to the input of the regulator, in case the output capacitance is too big compared to the input capacitance and the chip and the display doesn't drain it quick enough, and when you turn it off you end up with a higher voltage on the output than the input. You can damage the regulator. Anyway, I decided the thing takes about 10 milliamps, so it's probably safe enough to having 20 microfarads there with the 10 milliamp draw, and it's going to discharge pretty quick anyway. So that should be right without the diode. But the other thing I've decided to do, because what I originally did is I put the two big X7R capacitors here on the output of the regulator, the two 10 mics, making it 20 microfarads, and I moved the 10 microfarad to the input, where it was originally a 100 nanofarad cap, and I bypassed the Schottky diode and the 150 ohm resistor. Anyways, what I've done is I've removed the diode, and the 10 microfarad capacitors that were originally on the output of the regulator, I've moved them to the original position of the 100 nanofarad capacitors, instead of just, if you look at the other video, I just bodged it just sitting sideways across positive to negative there. But I decided to just use the pre-existing 100 nanofarad space for it. It's just neater, you know. Now, what I'm going to do is I'm going to add an additional capacitor. Before, I had this 1 microfarad capacitor across the rail here, and I wasn't thinking, because see, originally there was 100 nanofarads there, so in my head I was thinking, alright, I'm going up to from 100 nano to 1 microfarad, but towards the end of the video I ended up putting the 10 microfarad cap there too. They're both little ceramics, the ESR goes down as the frequency goes up. The point I'm getting at is there's no point in having that 1 microfarad cap there, just the 10 nanofarad will do the trick. But what I did want to do was take out the diode and add an electrolytic capacitor here, which is obviously only good at low frequencies, but for bulk storage reasons. And I wanted it to be like 4 or 5 times the value of the output of the regulator. So I'm just gonna, because I'm only running this off 12 volts, I'm just gonna get a 16 volt 100 microfarad cap. I've already done all the rest of the work. I've installed the 1 mic cap on the board that we did the voltage divider mod on. I've moved the 10 mic cap from there to where the 100 nanofarad was on the input. I've added the two 10 microfarad X7Rs on the output of the regulator. I've shorted across the Schottky diode and the resistor with a link, just like on this one. The only thing left to do on both of these, well, this one I've still got to redo these two resistors like that basically. But this bottom one and this one, the thing that I want to do now is add this capacitor and give you guys a look. So I'll just go get the capacitor. I'll be back in a sec. Alright, I'm back. I was just having a look in my inventory, and I've got quite a few 16 volt 100 mic caps there. I also have some low ESR ones, but we don't really need that for this application, especially with the little ceramic capacitor there too. Because the oscillation was at a higher frequency, so the ceramic cap will be taking care of that. We just want the electrolytic basically for DC reasons as a bulk storage device to make the input capacitance bigger than the output capacitance. Now, in another video, I was showcasing these cheap ass components I bought in a kit and how I'm unsure of the quality of them and whatnot, and how some are just terrible. By the way, something I forgot to point out in that video is all the ceramic capacitors, this is a good one of mine, but in that kit, around the edges, the stuff it's dipped in, the coating, was that thin ceramic was exposed to the environment, letting moisture get in. So again, they're terrible there. Anyway, these electrolytics, I tested them with voltage and they actually held up to about 20% over voltage, or at least 10% over voltage, and I'd end up soak testing them and they didn't pop. But when I measured the capacitance on them, the capacitance value would be a little bit smaller than what it's advertised as, but the ESR was actually on and the voltage was actually on, so I couldn't complain about that. So I'm just going to set this to 120 hertz. Take it out of automatic mode. Make sure it's in series mode. Oh. Go back to 120 hertz. I want to look at ESR and capacitance. Right. So yeah, okay. That's fine. The reason I wanted to test that quickly is because the ones I've got are a lot bigger and I'm trying to save space on this little board, so because it's only being run on 12 volts and it's only for DC bulk storage reasons, I'll be happy to use one of those cheap little caps. But yeah, I just wanted to point that out because, like, there's a place for everything, right? And I was considering throwing those just in the bin because by my standards they were just absolutely crap quality. Look, this is hilarious. Where it says vent, it's spelt VEHT. That's wrong. Anyways, like, yeah, the quality's that bad I was going to throw them out, but for this they'll do fine. They're 100 mic, 1.6 ohms ESR at 120 hertz. Yeah, it'll be fine for this application, and the advantage is they're small, so I can get them in there nice and tight. So I'll just pause the video whilst I form the leads up quickly, and then I'll come back. Alright, I formed the legs up how I want them, and I'm just going to pre-tin them because I've got a sort of, I don't know what the term is for it when you're doing a bodgy little, I mean, it's not bodgy if you've got enough flux on there already, and it's, if you know how to solder you can do this, but you shouldn't be carrying solder, like you don't go put solder on the tip of your iron and then walk it over to what you're working on and burn all the flux before it gets there, you know. But it's fine to tin legs and quickly reflow it into some existing solder. If it's not shiny, alright, if it's not shiny, then you know, obviously, no, it's no good. Get some flux on it, get some fresh solder on it, reflow it, right? But if it's all perfect and shiny, then you're good. It's just something you get used to after soldering for a long time. Alright, I'm only going to move this out the way one time so everyone can see in here, but this is the finished product. So we've got two 10 microfarad caps stacked on top of each other there, right? A 1 microfarad cap where the 100 nanofarad bypass cap was going straight to ground instead of a ground point in between this part and this part's star ground point. Let me just try and get this to focus. That's better. Sorry. in here we've got a, oh man, focus, a 10 microfarad ceramic capacitor and 100 microfarad electrolytic capacitor, and then underneath that we've got our little short where the 150 ohm resistor and Schottky diode was, and then obviously at the top our very much podgy resistive divider replacement. Look, I didn't have any way around that. I don't have a ton of SMD resistors, and I needed to adjust the divider to get the accuracy right on it, so, you know. But anyway, obviously I've still got to add the capacitor to this one and the resistive divider. I won't do that in this video because you guys have already seen all that. I just wanted to show one of these as a finished product, how it's going to look. Yeah, I'm happy with that. So that's how that's going to go. That's going to go back in its holder. And that's it. We'll put the little piece on for the plug connector. Done. So the next thing I've got to do is I've got to make my negative voltage follower up and put this back into the power supply and see if it's still causing noise. But I'll give you guys a hint. I've already done some testing and I think I still have a noise problem. Strangely enough, the oscillation problem in the panel meter might have only been in the panel meter and not been causing the noise problem in the power supply. And the reason I say that is because, look, I was just doing some tests before, basically with a resistor, just leaking current in from what supplies this to the sense wires, and that was giving me the same effect as having this in. So I'm not so sure that this oscillating was actually what was causing the noise on my power supply, but I've got a funny suspicion it was more the fact that because this is not 4-wire sensing, it's only 3-wire sensing, the sense wire is still referenced to the negative terminal on here, which is supplying power to it. These two wires power the meter, and it's sensing between here and here. I got a funny feeling what's happening is it's leaking some noise from either this wire or both into this, and that's how it's getting noise into my power supply. So I may have literally just fixed a problem for no reason, but there again, is it for no reason? If there was a problem already there, how long was it going to last for? You know, I discovered the input voltage rating was wrong. I discovered a lot of things whilst playing around with these meters, so I'm kind of happy I did, because even if I don't end up using them in this power supply, let's just say they end up not working out and I need to use a true 4-wire meter and I go and order 4-wire meters, at least I'll still have some really good 3-wire panel meters lying around for another project, because there's plenty of other things that I've got to build that don't need a 4-wire panel meter, and these will be more than great for. So I'm still happy either way, but I'll keep you guys updated and show you what happens when I put it back in the power supply with the voltage follower. We'll see what happens from there. Alright guys, I'll see you on the next one.